All right. Thank you, everyone, for coming over. This is the Understanding AI and Deep Learning session. Um, there is a bit of a delay, or that's Ryan. All right. Yep. Thank you all for joining. So this is the first Google Developers event in Australia, and bit of pressure in organizing it, but I think it's going to be all right. Sorry for the delay. The YouTube live stream wasn't working at the very last minute. My apologies. We'll just get started with a quick introduction of everyone in the next slide, and I'll just introduce you to what Developer Student Clubs is. So I'm Aditya Pujara, and I am the Developer Student Lead on campus from Google. And today we'll be presenting Understanding AI and Deep Learning and Developer Student Clubs. These are clubs all around the world. And so today's event will be organized by Developer Student Clubs from Google, AIML, Deeplearning.ai, they're our partner in crime, and the University of Adelaide. So DSC at the University of Adelaide. We're basically a group of clubs all around the world. What we do is we bridge the gap between theory and practice. So I think all of you have been aware of us from a while now. We're OSC, known as OSC on campus. Recently, we've been transitioning to being called Developer Student Club at the University of Adelaide. That's just our other name and now a recent name. What we do as a Developer Student Club is try to help students understand what these technical applications that you learn in university are in real life and using them in real life. And so today is the first launch event for Developer Student Clubs at the University of Adelaide and for Australia, because we were just recruited like a few months ago. So it's going to be amazing. I'd just like to introduce to you our speakers tonight. I promise I won't be going back and forth from the front to the back the entire time. As I was saying, Developer Student Clubs help students bridge the gap between theory and practice. We try to emphasize this because it's really important that students understand the difference between what you learn at university and what you actually apply in your workplace or anywhere else in your career. Today, we have a few speakers. Myself, Aditya Pujara, as I mentioned at the very start, Developer Student Lead. And I would like all the speakers to introduce themselves, starting from the left, please.
Hi, everyone. My name's Hayden Faulkner. I'm a final year PhD student with the Australian Institute of Machine Learning. Before that, I did an honours degree here at the University of Adelaide and an undergraduate degree in computer science. That's going back 10 years ago now, so quite a while. So at the moment, reaching the end of my PhD, I'm also working part-time for a couple of companies, smaller companies here in Adelaide, doing machine learning and deep learning based applications and stuff like that. Yeah, pass you over.
Hello, everybody. My name is Rafa. I'm a postdoc research fellow with Australian Institute of Machine Learning. I would like to first thanks the opportunity to speak.
Thank you.
And to come around. And I also would like to make an acknowledgement on behalf of me and my friends here. We would like to acknowledge and pay our respects to the Kaurna people, the traditional custodians whose ancestry lands we are gathering on. We acknowledge the deep feelings of attachment and relationship of Kaurna people to the country, and we respect and value their past, present, and ongoing connection to the land and cultural beliefs. All right.
Thank you.
I think it's very important that.
Absolutely.
And another point is a little bit about me. I've been at the Uni Adelaide for 5 years now. I originally came to pursue my PhD here, which I finished last year, and then I started working delivering my own research at the Australian Institute for Machine Learning. I'm very interested in the subject called visual question answering, and also another subject called zero-shot learning. Visual question answering is basically how we help computers to answer questions and based on a pair of a sentence and an image. And zero-shot learning is basically helping computers to classify or to identify novel knowledge based on no image whatsoever. All right, I will pass. Thank you.
Thanks, Rafa. So my name is Hassan Abbas Najad. So I'm a postdoc senior research fellow at the AIML. I did my PhD at ANU with machine learning, at that time Bayesian methods. When I joined AIML, I started working on computer vision, different applications of computer vision. I did a bit work in vision and language, bit of work in reinforcement learning, which has applications in robotics and navigation, and a bit of work with our industrial partners with delivering different products of machine learning essence for them to use.
Hi, I'm Violeta. I'm also a PhD student at AIML. I'm currently finishing my second year, and as well as Rafa, I work on visual question answering and other vision and language stuff. I've finished my bachelor in Russia. I had a specialization in computer science, and I also finished my master degree in computer science and computational engineering. I'm mostly interested in computer vision and natural language processing, and about how you can combine both these areas together.
Thank you all for your introduction. I would really like to introduce my team as well. Could you please come down here, and I'll just like to introduce you all. So that's my team, my core team for Developer Student Club on campus at the University of Adelaide. I'll just pass on the mic to my team so they can introduce themselves.
Hey guys, my name's Eric. I'm the Public Relations Officer for OSC.
I'm Chris. I'm the Vice President for OSC.
You can go into more detail than that. Hi, my name's Mitch Martinez. I'm Community Committee Advisor for the Open Source Collective, also President of Software Engineering Club in my fourth year of a Bachelor of Software Engineering.
Hello, I'm Suzanne, and I'm the marketing lead of OSC. Hello, everyone.
Thank you. All right, so let's just start with a few questions, very basic questions, very generic as well.
Myself as well.
And we've got Samuel as well on the line. Let's just introduce him real quick as well. Unfortunately, sure. I thought the call wasn't working. Oh, awesome.
Hi everyone. I'm Samuel Marks. I'm joining you from Sydney. I would be there, but obviously the flights are cancelled. I'm a Google developer expert in machine learning. It's a bit worrisome. The panel we're making you think that machine learning you need a PhD to do. I just submitted my PhD to University of Sydney just recently this year. I'm waiting to hear back. My field of, apart from being a Google developer expert in machine learning, my field of research is in medical diagnostics, specifically classification using images. And you know, I've set up a charity around that, and you'll find about 350 odd open source repositories that I've created over on GitHub. And you know, I'll get into that later in the talk. Later in the proceedings, kind of talking about how to contribute to open source, how to solve problems with AI, and kind of what the charity that I've created out of my doctoral research and what that will do for kind of mass screening. Thank you for the opportunity.
Thank you, Mr. Samuel. For anyone who hasn't been able to hear the video call. Mrs. Samuel Marks is a Google expert in machine learning, and he's a great contributor to open source technologies as well. We'll be including him throughout the meeting. Unfortunately, he can't be here in person. He's in Sydney. A lot of tough conditions coming in and out from here. So we'll just have to talk to him through the Google Meets platform. During the meeting, I'll just jump back and forth between the presentation and Dr. Samuel Marks can join us in those times. Thank you again. All right, so let's get started with some questions. And Mr. Marks, if you can hear me, if you could also join into the conversation, let's put in a queue. So going from left to right, and then Mr. Samuel Marks, if that will be all right. All right, let's get started. And
Maybe
during the course of the questions, please jump in to if you want to add something. We'll just hand it over to you. What we'll do is there is 4 questions and 5 speakers. We'll just get everyone to jump in at any point in time, but we'll go in order. So from left to right for 4 questions, and Mr. Samuel Marks can add in at any point in time. All right, let's get started. What is AI?
Yeah, that is a surprisingly tough question because I bet my answer is going to be different to everyone else's answer.
Absolutely.
Here. So, what is intelligence in general? Is a massive philosophical question, and therefore, what is artificial intelligence is even harder. To me, I think artificial intelligence is basically trying to build an artificial system, potentially that can be a computer, to display signs of intelligence. But again, what does intelligence mean? I suppose in our sense, our goal is often to try and mimic humans, to try and make an artificial thing as similar to a human as possible. But again, humans are very complex creatures, and whether intelligence is all you need to be human is a big question. So yeah, it's a hotly debated, very philosophical question, I think. Yeah, does anyone else have their 2 cents?
What do you think about the hype around AI and machine learning? Because as a student myself, when I first came into university, first few words that I was taught was AI and ML are the big things in the computer world. And getting involved in them just means you have to be really smart or you have to be really experienced. And what Google wants and intends to do is to bridge that gap, even with developer student clubs and everything else. They want to make people understand that, as Samuel Marks said, you don't always need a PhD, but also it's all about actually understanding the applications and putting them from theory into practice. What are your takes on this?
Yeah, 100%. I was similarly brought up through my university thinking that PhD is what you needed to do this kind of stuff. But more and more these days, you don't need that to be successful in this field. Experience goes a lot further than a PhD does, I think. If you can show that you have passion and skills in this field, then that's what matters to employers. In terms of AI being the big thing at the moment, I think part of that is definitely a bit of false hype.
Yeah.
But again, we're all in this field, so I can't say too much negative about it. But
well, allow me to say some negative things about it.
Go on, Samuel.
Yes, please.
So I think the main thing with AI is it's a marketing term. Just forget all the hype and look at the problem you want to solve. What algorithms are there out there that can solve that problem? And most importantly, what can't be solved. Once you figure out what can't be solved, then that really narrows down what you can solve. And then it's just, all right, I applied this algorithm. Oh, look at that weird neural network out of Facebook research or Google research or whatever. Let's try that. You throw in some data, you train your network. If it performs well enough, then you deploy it and you get onto your next problem, whether it's another AI problem or a different problem in your business or student or charity life.
I think one important thing to add, I just look back in time when I was doing my undergrads and trying to figure out what to do. Yes, AI, it's a bit buzzword. Everyone talks about AI. Everyone thinks that AI will solve all the problems, but that shouldn't be your motivation to do AI. You're really looking for something that you're passionate about. And like, I found myself in AI, but AI, we can look at AI as a goal for mankind itself. As Hayden was talking about, we are looking for some sort of machinery that is close to us, that will perform the same task as we do, because somehow if we have a machinery that can do that, it can makes our life easier, right? So you don't want to go and do groceries, but if you have an artificial intelligence that can operate this kind of task, then you can get more time to spend with your family or with your kids. Well, when you guys have kids, at least.
And even like for students themselves, what we've heard is AI is completely separate to everything else in tech, like ML and AI and deep learning. Even apart from being buzzwords, they're also considered to be godly by themselves, because you know, this flow chart, this chart here, it's not a flow chart, but this chart here that you can see, I don't know if the speakers agree with this, but this chart sort of tells you that ML sits in the middle of so many different things, like big data, algorithms, and technology. I'd like to hear your take on this, on what you think, what brings ML together. Is it all these three things? Is it what it is, or
I think you need to throw in another 100 circles.
what's that?
I think you should throw in another 100 circles into your Venn diagram.
That's right. Because these are the three terms that are very commonly associated with machine learning in terms of what it's made out of, like algorithms, big data, and technology as itself. Those three things combined to give ML is what people think. But is that true? What is your take on this?
I feel like big data and algorithms, yeah, machine learning's in the middle, but both big data and algorithms and technology, really. So I just think technology includes both of those things. But I think maybe I'll pass it over to someone else to talk about what machine learning is, and then we can maybe put that in a bit more better context.
I'll just pass on this mic here towards the end as well. Thank you.
Yeah, it's a bit strange. I don't know how you separate technology and algorithms. But I think machine learning is just a way how we can describe the process of learning or problem solving. So machine learning is used to solve some problem, and it is done by machine. That's it. That's how we describe it, but it can be generally anything.
All right, who ever heard of Prolog here? Have you? Oh my gosh, how old are you? So when we go back in time and people will start thinking about the idea of artificial intelligence, they first thought, oh, we can just describe everything that a robot would have to do. And then they start doing this, and then they created like 100 routines, and then the robot could barely walk a little bit. And then they add another 1,000 routines on the top of it, and then the robot maybe could just step up one step of that step. And then they just realized that adding all those routines and creating it and handcrafting everything was just impossible. You cannot
That's right.
describe the world, so the computer system will be able to to perform every single task. So the computer, the robot, needed to learn by itself. Therefore, we created a paradigm called machine learning. And then on machine learning, we start understanding and studying how we can teach machines to do things close to the way that we do without having to handcraft every single thing that the machine had to do.
Yeah, and I think it's for some cases when even people don't fully understand how to solve something. For example, a simple task, you need to classify an image to be an image of a cat or a dog. Yeah, how can you describe that? You will just look at the image and you will, because you've seen many cats and you've seen many dogs, you know how to distinguish them. But how can you describe that into separate rules? Like, it's an animal and it has fur, but what else? How can you tell if it's a dog or a cat? Yeah. So I think people just thought that, okay, we have many images of cats and we have many images of dogs. So we'll just put them into some model and it will learn by itself. So that's how I think people started to use machine learning for the first time.
And with the fact that data evolves over time and the fact that we keep adding new data to our existing models, and the fact that we can't, as you mentioned, can't classify a cat, like we can do that in our heads, but a computer, I mean, how can it classify that by itself without getting the data and doing all the analysis on it? So those two things, the ability to transform with more data and with the addition of more data, and also being able to classify and work on things which cannot be explicitly mentioned or understood by a computer by itself, is what machine learning does, if I'm not wrong.
So I think I'll go back to your AI question.
Please do.
So I think the best way that you can explain AI, in my opinion, is what Alan Turing basically said AI is. If you can basically, if it can imitate humans, if you can't tell that it's a human or a machine, then that's AI, and that's what the goal is. And different to what you said your bachelor degree was, I remember when I was doing my bachelor's, I asked about AI from one of my professors, and he said, it's something theoretical that has no application. It's very out there, and you won't be able to use it in practical applications. And when I started doing my PhD, then it started to get a momentum, and you could really solve problems with it. And part of it was the circles that you have. Part of it was that you now have more data, and you have the mechanism really to store that amount of data, and you have different systems to collect those data. And then you have you have those technology, and then you have technologies to process that data. So many of the algorithms that we have now are the algorithms that we had in 80s, but we couldn't use them because they were they were so computationally expensive that you couldn't really use them until 2010s and 11 when they started to take off. Like GPUs became more, and you had interfaces to use them. So these are all part of what make machine learning and AI as a buzzword. And I think part of the hype is that it can solve it out of that vision that we all had about how artificial intelligence would look like. We started to see some small applications that we can now solve, like image classification with a very good accuracy. We can now distinguish between different classes, and people got excited about it. And I think there are many applications that are relatively easy now to solve, and it would help us progress towards the next steps, but there would be more and more challenges. So people might not get what they expected in terms of the AI objective that they have, or what they envision their objective would look like, but at least along the way we would solve some of the problems that could have impacts in different technologies or in different industries.
I think wrapping up this question and the diagram, I think the answer would be basically yes, those things are important for machine learning, but they are not what is driving
machine learning is.
Yeah, no,
Yeah.
machine learning, it's was developed primer to all those things. Those things have boosted machine learning of course, but it's not what machine learning is. So they don't compose machine learning. They are.
That's right.
You can add.
I can add that. So machine learning, you can think of it as you write the program now. So you all are familiar with programming now. With programming, you have to specify instructions line by line. And in many cases, like Violetta said, we cannot really explain that. We cannot write those lines. But we know what's the input and what's the output, what to expect the output to be. So we basically put all those data, all those pairs of inputs and outputs, and we try to basically find a connection between those inputs and outputs. And that's basically machine learning. So it's kind of giving the machines the ability to learn from data, to program themselves in a sense.
So
and I should just comment that it's important to make the distinction.
That's Samuel Marks, by the way.
Between supervised learning and unsupervised learning. So if you're given like a big data sets of cats and dogs, then and the goal is to figure out which is a cat and which is a dog, then that's a supervised learning task. Whereas an unsupervised learning task might be you're given a whole bunch of images of different things and you're trying to cluster them, but you don't know what the categories that you're clustering. So it's just like cluster 0, cluster 1, cluster 3. And a human might look through these clusters and realize that, oh, you've written a neural network that's really good at identifying people. Oh, you've written one that's really good at identifying shoe color. And they can figure that out, but the algorithm doesn't actually know what it's classifying. So that's kind of a good way of separating machine learning into two sub problems.
And I think with AI and machine learning, these two terms are very closely used on a daily basis when we talk about it. Like AI is assumed to be machine learning and machine learning is assumed to be AI. Is that what it is? Is there a difference between these two terms, or why is it used so frequently together?
I think machine learning is a very small subset of AI, which is happened to be successful at this time period because of the reasons discussed. I think AI is a very big stretch goal and something that I don't think personally we're anywhere near actually doing. Sure, we have machine learning techniques at very specific problems that are better than humans at those specific problems, but machine learning is still very naive in what it's doing. It's quite just a lot of pattern matching and mathematics, and it's not particularly conscious or really intelligent. I don't think it's a bit of a magic trick, really. It kind of gives off the impression that it's intelligent, but yeah, I don't know if it is. It's just a way of going from one thing to another, translating one thing to another at this stage.
Well, I think it all depends on how you define AI, because for some people, AI, it should be something like a real human brain, but just in a computer. For myself, personally, it doesn't need to be a real reasoning or a real intelligence, as long as it looks like a human or very close to human. I don't know if you heard about it. It is called Chinese room experiment, if I'm not mistaken. No, so it's not a real experiment.
Could you please describe it? Yeah.
Yeah, so it's just an idea. So imagine that there is a room and there is a person inside that room who doesn't speak Chinese at all. But he has a book which contains, I don't know, all possible rules about how can you translate from English to Chinese and back. And someone passes inside that room a note with English text, and a person, by using these rules, can fully correctly translate this text into Chinese and output Chinese text. So everyone who's outside that room, yeah, what you see, you have an English text, you pass it there, and you get in Chinese translation, which is linguistically correct. So you think that whatever is inside that room is performing real translation. So it can understand both English and Chinese and can do translation pretty well. So it is an intelligence. But the person inside the room, he just has like very precise rules, but he himself doesn't know Chinese at all. So, and we can think of AI in a similar way. So as long as AI do something very with the high accuracy, yeah, we won't actually care if AI itself understands something or has any intelligence.
And I think we get into another big problem, and this is one of the biggest challenges in machine learning. Imagine this Chinese person inside the room, okay? But language is always evolving. Am I correct? So imagine the same person after 10 years, he will keep translating into a 10 years in the past vocabulary, right?
Yeah, because we get new words like
Exactly.
very quickly.
And
yeah.
that's the problem. One of the issues, and that's why Hayden said that we are as far from intelligence as possible now, because you train or you teach your machine learning model how to classify cats and dogs, but then you show a new image from a completely different object or animal, and it won't be able to identify because it's based on a few rules that were learned from a data set.
And like machine learning, it solves the problem of having to write a program and repeatedly update it for everything new that you want to add. For instance, if I have, like you mentioned, you're talking about a cat and a program, a machine learning model is identifying a cat. Now, if you wanted to add the rule of different animals, and if you train the model to just find animals by itself, and the model has been trained for cats, the transition between allowing the model to identify an animal from identifying a cat, it would take ages by programming it individually for each routine.
So here's the thing: we are not focusing in programming routines. That's not what machine learning expect from us. So we are teaching the computer to learn those routines by themselves. But in certain ways, teaching a computer to do that requires us to define very constrained boundaries. So for instance, when we are talking about a certain classes of machine learning models, we are basically saying, look, model or black box or Chinese room, I'm always going to give you an image 256 by 256. And on this image, 256 by 256, you will have to choose between 10 animals. All right. And then you just constantly keep giving the same image 256 by 256, and the model will constantly be telling you, it's a cat, it's a dog, it's a cat, it's a dog, now it's a horse, monkey. All right. And then you will be constantly correcting your model on this.
That's right.
But now you want to add a new class, you have a big problem.
Big problem.
Yeah.
Agreed. And because if you are training a model to be scalable, you would want to have it be able to do those things, correct?
The term that we use for this is generalistic. If you want your model to generalize, then you will have to figure out how to do it. And that's when machine learning as a field is starting getting very diverse, because you have models that are worried about the fact that you have to add new classes in the world, or you will have all sorts of models and they will have different task goals.
So now we would like to add another question, another term, which sort of relates to both of them. And it's always been surrounding the hype as well, deep learning. And before we move on to that, I just want to add that our partner today is deeplearning.ai. And they've partnered with us for this event and for many events to come. So what exactly is deep learning and how does it relate to AI and machine learning?
All right. So let's get back a few steps on when we were talking about the prologue, right? So what was the big problem with the prologue? We had to develop a lot of routines to teach a robot how to climb the stairs, and that was a headache, to don't say any other thing. So during 30 or 40 years, we had a field in computer science called computer vision. And computer vision, who had lessons in computer vision? All right. So computer vision is basically the task of helping computers to understand the world through images or videos. But computer vision was so heavily studied in terms of geometry. We wanted to describe images by the geometry, by the nuances, by the gradients in the image. So we were always trying to find a way to describe an image based on the appearances. But this led the researchers to do exactly what we were doing with the prologue, trying to, if there is a triangle close to a circle, this might be an ear. So let's represent an ear with those bunch of numbers. So we started handcrafting a lot of features for images, all right? But that wasn't feasible because every day a new class might appear or something like that. So then back in 2014, more or less, people start creating, a set of model called neural networks or artificial neural networks. And basically what they did, they applied the machine learning paradigm to learn how to describe an image. So instead of having to handcraft all the features that you want to extract from an image, what sort of features you could extract from an image? Color, you could extract shapes, geometry, you could, what else? I don't know. Yeah, edges, and things like this. Now you ask a machine learning model to learn it for you. And this was only possible because of gaming PCs. Who knew that gaming PCs would help us, right? So GPUs, because GPUs are fucking good solving linear algebra problems.
Censored.
Yeah, so they are really good solving linear algebra problems. And also big data, because now we have a lot of images to teach computers how to see the world.
That's right. And Dr. Samuel Marks, do you want to add something to this, or?
Sure. I should note I'm not a doctor yet. I've only submitted. I think a big and you might want to just resize me on the screen so that people can see.
Absolutely, I'll just bring that up.
I think that a big difference between deep learning and ML and AI is that usually when people talk about deep learning, they're talking about artificial neural networks, and the deep in deep learning refers to how many layers of neurons. Now, keep in mind that this terminology, like we use brain and artificial intelligence and neural networks. Think of these as inspired. Don't think of these as like the next science fiction blockbuster. They're useful, but in practical implementations, you might break like laws of biology. And we've got nowhere near the amount of complexity in our neural networks, even the best ones from Google and Microsoft and Facebook. It doesn't even come close to what you get in a human brain. Deep learning has shown to beat the best algorithms that were previously leading the fray. Specifically support vector machines. Not for every problem, but for a whole bunch of interesting problems that had plagued the AI community for a long time. And deep learning is pretty easy to get started with, especially with a technique called transfer learning, which allows you to kind of take a section from a successful neural network run, so say with millions of images, and you just take everything but the top layer and it's might be a few hundred megabytes, and then you can plug that into solving your specific problem. So that was a big breakthrough in neural networking that kind of made everyone really excited, because now people with no real knowledge about how AI is, what AI is, who don't know the first thing about statistics, can write like 10 lines of Python code or JavaScript code or whatever, chuck it into their phone, and put it in front of someone's face and identify who they are, or identify what disease they have. So that's the real benefit of deep learning, that you can take, not unskilled people can take it from the success of skilled people, and that's when you have like a proper revolution. That industrial revolution was all because you could actually separate and divide labor.
So to add a point to what Rafa and Samuel explained, it's all the matter of representation. So it came to be because the problem was we don't have a proper representation of the world for a particular problem or a particular task. And deep learning is particularly good because it's deep, because it has all these characteristics. It basically learns the representation of the world given your data and given your task. So that's why it became so popular and powerful, because then you don't have to specify the representations by hand. It would learn it from your data.
Well, about deep learning, and also just jumping ahead to the question on how they relate, just to summarize a bit. Yeah.
I'll bring the slide up.
So like AI is like the general goal, the general thing. We want computers to be like humans. Machine learning is a step towards that direction, where we're not explicitly programming computers to solve particular problems. We're allowing them to learn from data from these problems in very closed settings as well, though. And then deep learning is then a part of machine learning. And as Samuel said, it's deep because of the networks that we're using are often deep networks, and they're deep because that gives them the ability to learn more representations or more complex representations of the data to give better results. So really, they're just subsets of each other. And yeah, they can basically be used pretty interchangeably in the media and around the place. So yeah.
All right. So the format for what we're going to do next is basically going to be like, we have a lot of prizes here at the back. If anyone has questions, go ahead and ask them. And what we'll do is hand out prizes for questions you ask. Something to note that we have very few bottles and too many Lego androids. So, all right. Who wants to start? All right. Yeah, let's start from there. What's your question? Yeah. Let me just pass this mic to you.
I have a question as I'm a computer science student.
1 second. Let me just. There you go.
I'm a computer science student of University of Adelaide, and now I'm in my 2nd year. And my question is, like, as the machine learning technology goes so fast, how about our like we computer science students? Are we going to lose our jobs? Yeah, because I think the machines can be more and more efficient. Then they have the more ability to like I'm also worried about like if that one day that we don't need a human like software engineer, that the machine can code instead of us.
I saw a research paper out of Facebook AI that they built a neural network to automate the translation of programming languages. So that was quite exciting. So that suddenly you want better speed for your application, we'll rewrite it in C, but then you write it in Java and the Java will be rewritten in C. So there's really some cool research out there. I think don't be afraid of change. The best thing to do about people automating your job is to automate your job first. You know, get ahead of the fray, make a bunch of money, have fun.
That's right. Another question. All right. Yeah, go ahead.
Now, I'm not sure if you guys are data scientists at all, but I have a question because I'm a junior data scientist, and I'm kind of trying to get into the industry, but I'm faced with a lot of different questions. For example, there are things like data analysts, data engineers, and then data scientists. And I was just wondering, like, do I have to become all three of those things? Like, how does that work? Do you guys deal with data scientists or their teams? Do you have anything to answer? Thank you.
So all of those words, they ended up being buzzwords. All right. So data science is just something just created, but it's something that has been emerging from other professions, you know. I think it goes towards his question as well. So this field is a field that's constantly moving. So once you finish your degree or you're already a young professional in the market, you should be prepared for change. All right. And these basically means titles and things like that. Like your job position will migrate or will change with time. So data science maybe will just become something else, but the task itself will be the same. So in terms of the names for today, data science and data analysts, they will really be related to the task that you're undertaking. So if you're dealing more with the data, if you're like statistically analyzing the data and maybe trying to clean out the rubbish, you know, bad image in the data, or you're worried about how biased your data set is, if you have too many classes of one object and too little classes of the other object, that should be more related to data analysts. If you're doing more the machine learning bit, you're training model, you're preparing the data to get and train the model, then you would be more like a data scientist. But there is also the part of statistically analyzing the data that you get out of those models, generating cool graphs and cool things to show to the panel of the company. So the way that I see, they have those three main streams, and it depends on how big the company that you work is. All right. So if you work in a big company, they will have a team for data analysis, another team for just machine learning, and another team just for creating cool graphs and demonstrating stuff. If you work in a small company, you might have to do everything.
All right. Does anyone have? Oh.
Yeah, I think I would also answer that the same way I answered the previous questioner. You know, don't get slow. You know, every week should be like your third assignment for your subject, and if it isn't, then you're not working hard enough. Learn every programming language, learn every AI bit that you can master, learn how to speak to people, learn how to present. Never stop learning, because otherwise, you know, the panel will take your jobs.
All right. Next question.
So, what are like the big major ethical concerns that relate to AI and machine learning that are currently happening now? So, one thing I'm thinking of is that if we have, let's say, an AI that's designed to streamline the hiring process, would that potentially take in the biases human beings have showcased in the past with hiring, such as based on race or gender? Is those concerns that have to be taken in when developing AI?
That's a beautiful question, and it's actually a really hot topic at the moment. How the data set or the database that you're using to train your AI can heavily bias the models towards some sort of behavior or some sort of things. Yeah, so this is a problem There are a few research groups that have been looking to ethics specifically, but it's still not conclusive, right? So we don't have anything. I don't know.
Yeah, the flip side of it is that if you have a machine, then they might not have the human biases that you could have. But as Rafa said, it's a very hot topic, and it's a very difficult thing to characterize, because we have different ideas about what the biases are really, and quantifying that in models, it's hard to do.
And I think it's very important that researchers in those fields and engineers on those fields take the time to worry about this kind of stuff, because if we don't do that, then I don't know if you guys have seen the narrative from Elon Musk, but then his narrative would become true, right? If we don't look into that, if we don't address those issues, then yes, of course, machine have a large potential to harm mankind. But if we look into those things and if we study this carefully, then we shouldn't have to worry about it.
So I would assume there's something like a moderation team, or like a board of people trying to moderate the use and the applications of AI to have a workaround from the ethics.
Yeah, so I think there are two ways to look into this problem, and I'm not talking with large property on this field, because I don't study specifically how to address ethics and things like that. But for instance, you might have a machine learning model in production in a company, and you definitely should have the resources that people can just tell that the machine learning has been racist, or it has used improper language or something like that. But when it comes into training machine learnings, you might have a biased data set. You might have not enough diversity of human beings, and you might be discriminating. For instance, you were talking about the HR process. Like, let's say you have a machine learning model that's analyzing photos of people, and you don't have enough colored people, for instance. All right, so the machine learning might be biased on hiring only white people, for instance. Okay, so those things need to be taken in consideration.
So it's all about how you train the data, and
it's what sort of data you have available.
And what sort of data you use.
Because again, the machine learning models, they are learning routines, they are learning specificities. What is the word? Specificities on the data. All right. Thank you, Haida. So if you don't have enough data to cover the specificities, that word that you wanna, then your model will be biased.
There was a famous example in bank insurance, or the insurance industry, where they refused. I think it was they refused a bunch of black people credit. And when they were asked to say, like, all right, why did you refuse them credit? Because it was a deep neural network, they actually couldn't show, because it's a bit of a black box. There's a whole explainable AI thing now, but back then they couldn't actually show, so there was a big settlement and they lost the case. But it also depends what your research is in. So in my research, it helps for me to be very specific. I want to know the more racist, the more sexist, the more of those things that my algorithm is, the more accurate it is. And that's very important, because my research is in glaucoma and diabetic retinopathy. So if I can figure out that, you having a black ethnicity means that you're in the highest risk group for glaucoma, I'm not going to ignore that from my neural network. That's the most important thing to know, because, that should increase the bias of all your terms. And, you can have some training data set to improve that. And then Japanese are the next highest risk group. And whites are the lowest risk group. Well, actually, Aboriginals are the lowest risk group, but whites are the lowest big population risk group. So it's important to, not just dismiss the advantage of being discriminatory.
Yeah. I just want to say that people who use AI methods or who create, they just should understand their responsibility, is that they can't just blame everything for their model. It's like, oh, my model was overfitted, that's why it is so biased and racist or something. They need to understand how they can actually change it.
Yeah, and we're getting into the stage now where some models and some applications can, do real harm to people's lives. And researchers are maybe a bit better late than never, starting to really consider ethics in their methodologies and releasing of algorithms and methods. Yeah.
I'll just change the slides now. All right, thank you, Suzanne. Let's jump on to.
English or whatever, and it spits back another language. And you're also talking about, you give the network input and it gives you back output, and that's not necessarily intelligent. So what would you describe as intelligence in that situation? And what does the inside of the room look like if we're describing some kind of technological intelligence?
That is a very philosophical question because I have no idea how to define intelligence. That's the problem.
Yeah, is the book intelligent because it has all of the references between the two languages? Is the person intelligent because they can read the book?
That's what I get. Because you can only really give it some framework. So is it a matter of the specificity of the framework that defines intelligence, or is it always just going to be, okay, we give it input, it gives us back output, that's great?
So I think the other part of it is the reasoning process and how you explain it as well. So one problem that we have now, and we kind of touched upon, is that basically the models that we have, input output, and with the Chinese room question, you give it a text, and then you expect it to be able to explain and go beyond the input that you provide. We don't have that now, and we don't really have the capability for the models to explain. I mean, they can explain. There are tricks to make it work, but in a sense, to be able to reason beyond the data that it was given, to take advantage of the knowledge that we might be able to take advantage of, to be able to expand the knowledge they already know and reason and explain that reasoning mechanism. I think that would be another level that would kind of make it a bit more, I guess, intelligent looking. But yeah, it's a very philosophical question that we don't know.
I think in terms of machines, when we talk about machines being intelligent, it basically means a sort of machine. It could be a humanoid robot that you ask it to do something for you, and it would be able to do with little training or with no training at all. So that's what we are talking about. It's more like, just empowering machines to make your life easier. That does not require a lot of engineering from you. You just say, robot, clean the room for me.
I didn't really mean for the question to be super philosophical, just that, if you ask me a question, you expect me to respond in the way that if you give the room.
Yeah, and this is a task on itself, right? You're asking, what is, when you talk to your friend, I don't remember, what is the capital of France? And then the person says to you, Paris, right? So this is the kind of task that you might want the robot to interact with you, okay? And it does not need to feel like humanistic. You don't need to feel that the robot is a person that you can go. Of course, that some people might want that from their robots, but it's basically regarding tasks that we perform that we would like robots to do for us or machines to do for us. So you don't want to have to worry about cooking, for instance, right? It's boring cooking. Well, you might use it as an experience, but cooking every day for eating is boring. And if you have a machine that cook for you, you just sit on the table, they serve you, and then you eat and say, "Thank you, robot," and then you get going to uni. That would be perfect. Oh, I need a robot to put my food in the microwave for me.
My aunt was in Japan about a year ago, and she showed me a fully automated McDonald's.
Whoa.
I still have to drive there. Not funny.
You're really late.
Oh, no, I think Domino's in the US have drone delivery.
Oh. So now we've got drones and a fully functional robotic McDonald's.
Now we
Now
just
we're
need something
talking.
to chew the food for us.
Just one thing I wanted to add to
A blender.
what Rafa said about like asking questions. Yeah, when we ask a person a question and he can answer immediately. One of the reason why, for example, I'm working on visual question answering now, because it's a very cool idea about how can we test AI, whether it is intelligent or not, by asking it some questions. And if a method are able to answer these questions, then probably it can reason about something or can understand something.
But reason is very different than having an opinion as well. So I don't know. Would you expect that an artificial intelligence has an opinion, or it just reason about things?
I will be afraid if an AI will have its own opinion, because it may be very different from what I would prefer.
All right, let's move on to the next slide. We've got some more questions. So what are the different applications of machine learning?
Vast and broad. I think machine learning can be applied to. No, there's a set of problems that machine learning can be applied to this stage. But in terms of that spans many different industries, from agriculture, healthcare, technology, transportation. So the applications are quite, the potential applications are quite vast. I just think anything that you can make decisions off of data in some way, machine learning might be able to be applied to that, assuming the data is somewhat structured and relatively easily interpretable, I think. Anyone else? Thoughts?
I think, and this is related to the first question, I think, is that anything that you can find some patterns in, and you can identify those patterns, you can probably automate them through machine learning. And I think to answer that question again, is that if you can do something creatively, so machines at the moment, they don't have creativity. So what we can do as humans is to create new things. So there would be always new jobs because we create new jobs, and we automate the old ones that are laborious, and you have they contain a lot of repetitive with a certain pattern tasks.
So I think he's referring to what creative things or innovative things can machines do beyond what they've already been able to do right now. Is that something that machine learning can create?
So I've seen paintings, I've seen musical compositions, all kinds of interesting creative elements.
There was some. I listened to this playlist, and I actually heard about the fact that I was listening to a song which was made by an AI. I'm not too sure about where it came from. Something like was made in IBM or something, and that song was on the top charts at one point. So, would you say that at one point in time, our creativity wouldn't be necessary anymore because artificial intelligence will be able to take over that as well?
Yeah,
No.
I think that again is very philosophical.
Very philosophical. Very philosophical.
So I think creativity to a certain extent. So I can give you an example of like music to a certain extent, art to a certain extent, I guess text to a certain extent, stories. These things we have machines now that they can do those. And we are doing a project with AIS, Australian Institute of Sport, and they want us to basically look into, like game of soccer, and basically model the game and tell them what's some strategies that they don't know. So given a a team, you want to know what way you can change your, I guess, team's approach to the game given the opponent so that you can win. Or we're working with the Paralympic team on table tennis, and they want to analyze and basically understand how they can beat their opponent through this, I guess, some sort of creativity. But the thing is that it looks like creativity to us, in my opinion, but it's like a very small modification in the observable universe for that model. They're usually within a space that we cannot really sometimes search. So it's basically think of it as a search based scenario that sometimes algorithms can search faster than us, then they can reach the point that we can. But it doesn't mean that they can take a massive step forward. The way that we can, explain ourselves, the way that we can, create. They might be very good at particular tasks, but connecting all these dots, connecting, for example, art, you can create, an AI now can create paintings, but it doesn't really understand the emotion that it has to express. Or it basically can create music, but it doesn't really know what emotions it want to trigger in its audience. And that's something that we, us humans, can do. And that's where I think the next generation of, so with programming, many of the programming tasks would be automated, I think, but not all. You still need people nowadays. You have graphical user interface. You can create a lot of things that back in the day you had to write massive amounts of code for. Now you can just import the library and call a function, and that's all, and it does everything for you. But but we need people who know and understand AI. We need people who can link those libraries in a creative way. So I think that's what I meant by creativity and innovation.
Yeah, it's pretty much back on the 70s, on the 80s, when they start getting spreadsheets on Windows. No, that wasn't even Windows, but when they start organizing tables and spreadsheets, the librarians went crazy. Like they thought they would lose their jobs and stuff like this, but it just speed up the process, and now they can do other sorts of jobs. As a computer scientist, you guys are not like monkeys that know how to program. You're learning how to solve problems, right? So you're learning how to look into a thing and create a solution. And it just happened that you use code to do this. But if machines can code for you, then it means that you only have to solve the problem. Then you can start looking into harder problems because you don't have to spend time programming. And that it gets back into the other bit of your question, which what are the applications that machine learning are really good nowadays? We have one application that's called classification. So you can look into image, you can look into text, and you can discriminate to what sort of information that is. And then if you have images of a cat, you can classify an image of a cat into a cat. If you have images of dogs, you can do the same, so on. A second task would be called segmentation. What segmentation means? You have an object in a scene, and you want to identify every pixel that belongs to that object. So in a photo of a cat, you basically would want to mask out the shape of the cat and say that every pixel inside that region belongs to that cat. It could be for any of the classes that we were talking about. Another one is called object detection, which is basically doing something very similar to segmentation, but instead of separating every pixel, you just wanted to approximate a region. So you can create a bounding box in the image and say, oh, here is the cat. And then each one of those tasks by itself, they will have several subtasks. And it gets into the transfer learning that Samuel was talking about. So one of the best models that helped to boost so much deep learning and machine learning and AI, it was really good in performing classification. They put together 1,000 classes, 1,000 different objects, and they gather millions of images of those objects. And then they train a machine learning model to learn how to classify those 1,000 objects, and it became really good. It was getting something like 99%. What did it get to 99? No. It got to some really nice number, very beautiful and bold number
in precision
in terms of accuracy. Yeah. And what they find out, do you guys remember how I told you that deep learning learn how to represent the features in an image? They start getting this feature representation, and that's what Samuel told about transfer learning. And this transfer learning, now you could, instead of classifying those 1,000 images, now you want to just classify among 10 animals, types of cats that you have. So you just use that network that was already good on representing stuff, and you can fine tune on your own task.
So like in our inboxes, we get spam and they get sorted into the spam folder automatically. And then we have the inbox. Would you say that that's how it was trained by user input when they initially trained a model? And when they couldn't recognize spam beyond a point, users would say, this is spam, and it would get added to the list of spam emails?
Yeah, possibly, yeah. That's exactly the approach. Based on your input.
Based on your input.
Based on your input, you can look into similarities and tell whether it's a spam email or not. Yeah, so this is kind of binary classification problem, right?
Like a yes or no.
Yeah. Another application on machine learning, it's what we call generative models, that you will get into the kind of model that can somehow generate art. So we have a lot of models that do that, but the main applications nowadays have been the generation of image and audio and all sorts of this kind of things. And I think I see the main usage of that nowadays is not for art, so anything that will entertain us, but mostly to train all the models on the top of it. So imagine, for instance, that you are training a self-driven car, a car to drive autonomously, and you have a very good video of you driving around Adelaide Hills during summer. And let's just say that for the matter of this example that it snows here, right? And then you wanted your car to perform exactly the same task, but with snow, you could just use one of those models that can generate image to imprint snow on the scene and train your autonomous car.
So add the fact that there is snow in the form of an image to existing.
Yeah, to an existing image.
All right. Do you want to add something?
I was just going to say, to address this question as well, I do think we are at the stage that machines can be creative, but it's in a very, very tight space, in a very small set of creativity. And again, nowhere near what humans and how humans can be creative. And that I think you're not going to lose your job. Your job's just going to evolve into a different kind of job. As Rafa said, the computer might be able to program for you, but you've still got to solve the problem. And I think that's going to be around at least in your lifetime.
In your applications that you work on as researchers in AI ML, have you encountered problems that you haven't seen before? Because over time, does it feel like the problems that you work on with AI and ML, they can be used with previous models that you've already trained?
So I spend a lot of time, especially recently, writing a machine learning meta framework. So kind of the idea is every machine learning framework comes with a predefined set of optimizers, a predefined set of loss functions, layers, etc., etc. They also come with a predefined model zoo and sometimes a third-party model zoo as well. These are things where you can take the transfer learning, for example, ResNet, EfficientNet, Big Transfer, which is important to look at, which is fairly new from Google. And you've got all these options from previous people's, how previous people have solved problems. And what my machine learning meta framework does is it exposes all of those. So you give your data set, and you can do a grid search and try every single solution to what every other person has tried in solving their own problems in the past. And you might think, well, why would I do a grid search? That's going to take a long time to run on my little computer. So then you can start building, genetic algorithms, hill climbing, Bayesian optimizers for both categorical and continuous variables. So I think it's important to we're standing on the shoulders of giants. Each of us knows very little, but what we can do is, especially in open source, you can open source big libraries and just take from everybody. Take from Google, take from Facebook, take from Microsoft, take from random researchers that you didn't hear about until like a minute ago, and just integrate their code into your application, try it against your data set. If it gets better results, then great. If it gets better results in a research context, then you might publish that. If it gets better results in a industry context, then you might make more money.
Yeah, and at the institute does do industry projects and has clients in that space. However, I believe we're very much research orientated and research focused, and so in that sense, the goal often within the institute is to create novel methods, publish papers, beat benchmarks, and so we're often pushed to achieve novel novel ideas and novel architectures, etc. However, I think there's a massive space in industry where a lot of the current architectures and techniques would work quite well to solve current problems. And I think that that's a big space to go into for your future, potentially not in research, but in industry. And there's a lot of problems out there that can be solved with the current techniques, I believe. Yeah, go on.
Building on that, it seems like you're trying to convey that things are quite limited and primitive in one sense, as in the applications, but also obviously incredibly advanced in another. What do you think about this kind of position in AI and the development, and how yours and our careers are going to fit into that space? And even further, do you wish you were kind of part of a different wave of this technology, before or sometime in the future?
I'm happy that I've reached AI now. I think that where it's hard to say where we fit on the great scheme of things of AI. I kind of think we're at the beginning of it, and I think there's a long way to go. So yeah, I'm not sure how to answer your question. Sorry. Did someone else?
I'm happy to jump in. I'm really excited to be in AI. This is the right time to be in AI. You look around you, and so few people are in the field. Everyone loves the buzzword. Every movie has it. I was meant to be in Laos last month, looking at running some screening programs there. Screening programs wouldn't be possible without AI, at least not for the very specialized eye diseases that I concentrate on. So with AI, it actually becomes not just cost effective, but also possible to screen, hundreds of millions of people. And that's, what I would, that's the focus of all my research and my charity, to kind of screen as many people as possible for blinding eye disease. So this is a great time to be here. And yes, the field is moving very fast. And yes, in 5 years, everything we're working on will be historic, and no one will really care. But you look at what problem you're solving. So eye disease problem in 5 years. Okay, someone's got a better algorithm than mine. Great, I'll use it. I've always been open source. And in the meantime, I've stopped this, or I've helped stop this many people from going blind. I think that's really what you need. You need a proper application, whether it's industry, charitable research, and show that you've actually made an impact. That's why it's great to be in AI, and now's a good time to be here.
Yeah, so just trying to clarify, okay? So from a research perspective, we are very, very far from actual AI, like something that can, just live by itself. But in a application point of view, the advances that we had in the previous years, they just can take us to such a different stage in terms of what we can do, what we can achieve. It's just that matter that machines are really good on repetitive stuff. And those few models that we've been creating in the past few years, they just can help in so many different tasks that are boring for us today, that it's very exciting. And being AI, I completely agree with Sam. We have such a prestige nowadays just because we do computer science or some sort of AI. I cannot count how many times when I just met someone and they said, "Oh, what do you do?" And I say, "Oh, I'm a researcher in AI," and they were like, "Wow, you must be very clever." So just breaking to you guys, I'm not that smart. I'm just perseverant, if I don't understand what the model do one time, I just kept insisting until I finally understand the thing. You know, that's about studying something. All right, it's hard to study something, but you need to be perseverant. Just keep insisting, I will learn this thing. Well, one day you eventually will, you know, and you will do great things. And this is a cool thing about being in AI nowadays. You can actually do a change in society, you know. You can actually do a change in the world, because you might create something that might be a life-changing game.
Just recently, people, some researchers have developed a way to screen people with cameras that actually identify people, and then they screen them at the same time. And I think AI, apart from helping us be lazy, it can also save lives. With the current pandemic, the camera and the monitoring the people's movements, safe distance, and all of that can really save lives as well.
Like, imagine, for instance, if you had a camera recording you full time while you're driving, and then if it realized that you're about to take a nap or something like that, it just, you know,
Gives you a little shock.
Yeah, exactly. That's
And
good.
it can also be used to enforce martial law in Melbourne. So that's the flip side. You got to think about the ethics of it.
Absolutely.
Yeah, just want to add to the previous question. Like, I think this time we are very lucky because of all the tools we have to work with AI. There are so many libraries and already made applications or information resources, data sets, and everything. So you can just start instantly just by loading the whole model and start working with that. You don't need to develop everything from scratch like you needed a couple of years ago.
All right. We'll jump to the next slide, but we'll hold up the questions for now.
Can I just
definitely
mention about an elephant in the room?
Definitely.
So and here is the catch, all right? AI is really cool and it gets a lot of things done, and you might actually get an astronomic pay slip, and this is really good. But you doing AI just for the astronomic pay slip is not gonna take you far, all right?
That's
so
right.
you should take AI, you should work on AI, you should pursue AI if you're intrinsically interested in this kind of problem, in solving problems this way, and trying to I'm not saying that you should look into all those math books and love it straight away, but you know, you should be motivated by it. Okay, I think that's just a thing that I should say.
We'll jump to the next slide because we're short on time. So automatically going forward. So what are the different machine learning systems that Suzanne, there's some issues with the slides. Is that on present mode? All right. So what are the different types of machine learning systems? We'll just ignore the presentation at the back.
I think we briefly discussed, right? So there are a few big fields like computer vision, natural language processing. Computer vision is basically using image to perform classification. Natural language processing is basically using sentences and text to draw information from the data. You have signal processing. You might want to analyze satellites signs or sensors, radars.
Yeah, they're like different fields of AI and machine learning. To go with the slide a bit more, Samuel's already touched a bit on supervised and unsupervised learning, but I'll just briefly reiterate that supervised learning is basically when we know our input data and we know our output data, and we fully supervise the model in learning that data, and it's basically just a translation task. We want to go from the input to the output, and we let the model work out how to do that. Whereas unsupervised learning, we don't really know the output. And so it kind of becomes a task of finding out finding a representation of the input, which we can extract information from. So some sort of like structured way to represent the input information and the input data. So yeah, that's kind of a summary of supervised and unsupervised learning.
And sometimes you want to combine the two. So for example, with explainable AI or a different technique, you might figure out here is the part of the image, like you said, doing image classification. Here's the part of the image that has the biggest impact on classification accuracy. And you might continually feed what is the most important part of the image into a separate neural network or like an ensemble, such that it will auto crop or auto mask the image. And so, for example, if you look at this screen over here, the only important thing might be the face. And it could figure out, all right, we need to ignore all of that. And you could think of that as an unclassified problem because it needs to figure out what parts of the image are important and what parts are not. And you don't tell them what parts are and what parts are not. And then you could use that to gather a large amount of data for a supervised learning problem, such as automatically removing the background from images. And suddenly you've got a huge data set that you've been able to develop in an unsupervised way or a semi-supervised way. So you can have some fun with these fields.
We're sort of short on time. We'll jump on to the next question as well, but thank you for answering that one. Apologies for the slides. So the process of ML, what is the process that you follow when you're applying machine learning to a given model? So we've got a little flowchart here. Just like to learn your approach to this. Is it different? Is it similar? What do you do when you train your model? How do you start?
I've got a much larger pipeline. So I kind of think about it, I work with surgeons, so I kind of think about it from their perspective. So they're a user, or they're like persona, whatever you want to call it. And what they do is they might collect some new data for me. Then they might classify that new data for me. Then they might release that data into a community outreach app that is used by non-medical people or by nurses or by people that aren't specialists to screen the community. And then you get the data back, and then you analyze the data that comes back, and then you build a neural network, and then they, in the meantime, they've classified other diseases. So then there are different apps, and you need to think like, can you do that entire pipeline without an engineer? And that's one area of my research at the moment to make myself redundant. The sooner the better. Big pipeline.
Yeah, I think that pipeline's pretty accurate. You have to understand the problem you're trying to solve, I think, is the main thing. Make sure you understand that well before you think about data and models. What was missing from that pipeline was modifying the model to better suit the problem after predicting and evaluating it. And especially, yeah, if you're in an industry setting, don't just understand the problem that the user or the client wants to solve. Understand it from their point of view, not from your point of view as an engineer and a scientist, because that doesn't really matter to them. They're the one giving you the money. So
I think it's even worse, to be honest. You probably, most likely, you have to teach your client what they want because they don't know, because they have a lot of misconceptions about AI. So if you think that developing a software by itself is already hard to control expectation, and get clear definitions for your client, when you're dealing with developing a software that uses AI, that escalates super quick, because sometimes they have an under expectation. That's a great case for you. But most of the cases, you will have a client expecting that you will just solve general AI. You're gonna create a robot that's gonna pick the kids, and that's gonna generate that report and all sorts of things. And you also have the cases where they just want AI on their business. They don't even know what AI is, but they want AI.
Just the hype. Just
Yeah,
want to
it's
have
just
the
the
hype on
hype,
their
because
name.
it is a hype sometimes.
Absolutely. All right. We'll very quickly jump onto the speaker questions that we have for our speakers tonight, and then we'll move on to student questions, at which point we'll give out the goodies. So starting off with the first one.
I'll take the first question.
Uh-huh.
No, that's a joke, because it's the panelists.
So yeah, what is AIML working on, or has worked on before, apart from the confidential projects that you've worked on?
Oh yeah.
Yeah, some that you would like to share with us.
So AML, it's a really cool thing, because we are the largest research group on the Southern Hemisphere.
Wow.
Working in AI. So we have close to 200 researchers here in Adelaide, which is a really cool thing, right?
Definitely.
And we are also among one of the largest and most prominent groups in computer vision and visual question answering and things like this. So our group, we have several professors there, and they are generally looking to computer vision problems, visual question answering problems, and a lot of subfields on that. We also have because we've been working in visual question answering problems. That's basically you give a sentence, which is a question, plus an image to a computer and expect it to reason upon this pair. We have a very large intersection with natural language processing as well. We have many clients there as well. We've got several projects with defense. We have several projects with industries such Lockheed Martin, and we have a lot of very fundamental research in our group as well. What else?
So the next one was, what is the future for AI or machine learning? What do you think? Where do you see this industry going in the future? I think we've already touched upon this, but if someone would like to add something.
The question that you can't, you don't have anything to say. So I think, yeah, we're moving towards more general algorithms. So the algorithms that we have now are very task specific. And part of what we discussed, and especially with your previous slide, was, you collect data, you train a model, you test it, you go back, maybe you have to collect more data, or you have to refine your model, and it's an iterative process. And we don't have algorithms that are very generalizable, in a sense that we can, we can easily just feed data and it trains and it works. So that's one thing that we're looking towards. The other thing is that we don't have, so like future learning that Rafa mentioned. So these algorithms require a lot of data. We don't have that sample efficiency, I guess, that with few examples you can, train a model in the same way that with humans, they ask a question, you provide an answer, and that's enough usually for them to, for example, see an apple, and from then on they know what apple is. So we don't have that. So there is there's a bright future for AI and machine learning, in my opinion, and there is a long way to go to get to the point that we are really happy with the AI and machine learning technologies that we've developed.
I think one thing I would be super happy if we could see in this lifespan, it's basically machines that can seed, that can take care of food, and that can harvest and pack things and send it it somewhere. So we wouldn't have to worry about food anymore. Food, it's a very serious issue for a lot of developing. Yeah. No, but food is a serious issue for a lot of developing
that's right.
countries, for instance. And it would
Absolutely.
be really awesome to see this working, you know, in our lifespan.
Would you say though that giving the responsibility to a machine in terms of the most critical thing that humans need, water and food, would you think that would be something that we would want to do?
We already do that.
We already do that, yeah.
We
Yeah,
already
and it's better
do
than
that.
government.
So I think they would help. So like, for example, drought is a serious issue in Australia. So if we can, like farmers, they usually have a very large farm. They don't know if there is leakage, for example. If you can have AI that can help with detecting those things, you don't waste as much water. If you have a better understanding of the soil, you don't really use that much water because they don't know how to use the water. Sometimes there are misuse with water. If you have better health systems, you can provide health services to even remote areas, so people can go in, talk to a machine, and they get at least a relatively good summary of their health, and if there is a serious issue, then they can be referred to humans for supervision. So like bushfire, so there's a project we've just started. Australia suffers from bushfire, and with many other countries. Can we do something using AI and using satellite images? We can detect and we can see remote regions that it would take humans ages to find, but we can detect those using AI, and that's I think exciting.
Absolutely. All right. We'll just take some questions from the audience. Let's see.
I'm very curious. Well, I don't know if this is a stupid question, but has, in your experience, has actual physical technology limited what you can do? So like computers limited what you can do, like with your theory and knowledge.
Because GPUs, like
First, there are never stupid questions.
Yep, absolutely.
There
This
might
was a good
have a
question.
stupid answer, but the questions are never stupid.
And the fact that like GPUs and like today, even as a student, even I would have a laptop with a GPU. Back in the day, GPUs were a big thing, and I think that's what was limiting AI up until now. Because I was reading just yesterday that the reason why even today I can sit on my laptop and try to train a machine learning model is because we have the technology available to do it. Apart just beyond the fact that we have theory and practical knowledge, the fact that we had hardware unavailable back then, but now we do have it available. I think maybe that is probably the reason why today would be more prominent and more accessible to other people to train models and get involved in AI.
Yeah, but I'm just wondering, maybe sometimes it's more of a problem with like the code not being efficient enough, for example, not actually the problem of the technology. I'm just wondering how that.
So that was what I wanted to mention, that the code itself could be an issue, because GPUs were there. I mean, they were not as powerful as they are today, but the technology for parallel processing over GPUs were not there. So the software couldn't catch up with the hardware to a certain point. And now, the software caught on, we don't have enough hardware for it, really. So so there is always fight for for more hardware, for more GPU time when we are close to the deadlines.
And there's also plenty of room for human optimization. So, I write a bunch of C code, write a bunch of Rust code. It's important to actually know how to develop things at a low level of the computer. You need to know that at some point it does generate assembly code, and that assembly code is actually written by microcode, and then the microcode has instructions under it. It's important to understand the full set, and then realize, like, why can't I solve this problem? Why can't I have real-time video processing when it's targeting facial recognition, but I can have it when it's removing people's backgrounds? What's missing? And actually understanding the full pipeline really helps to do that.
All right, that's a great answer. Yeah, please.
I've got a question of, learning a lot of maths and statistics in my master's right now, but just thinking how much of that maths and statistics really gets like used in your day-to-day work lives, or is it more just programming and using pre-packaged software and libraries? Would you say the balance is like how much maths, just raw maths do you do, how much stats?
We use a lot of math and physics. It depends on the sub problem that is being solved. So, for example, we recently did an industry project for an ASX listed company, and they wanted patient specific medical devices. And a big part of this was retention fitting. So you have to think like, what curve are we trying to fit? If it's too tight, then it causes the patient discomfort and maybe injury. If it's too loose, then it falls off and causes the same. So there was a lot of quite high level math there that needed to be applied. Though commonly, off the shelf libraries, technologies like big transfer, they'll solve most problems. It depends what you want to do. Do you want to spend all day doing math? If you do, then you'll find the right sub-problem that no one else has solved, and you'll be spending your days writing math.
I mean,
I recommend doing that.
It really depends on what you want to do. Yeah. So if you're looking to some application, off the shelf will do just fine. You need to understand what it's behind it. But imagine like sorting algorithms, first year comp sci, right? You learn about sorting algorithms, you learn how to implement them, but in your career you're never going to implement that thing for doing something. You will just use a library because it's already optimized and it gets into all those things. It was written in C++ and blah blah blah. But if you wanna tackle more research perspective, then you will have to go into maths, and you have to understand how the worlds behave and try to express it mathematically. And I think that's the most beautiful bit of it, by the way.
Yeah, absolutely. Because at the end of the day, if you're researching something that's brand new and no one's been involved in that, you would be expected to do things which are beyond libraries that already exist, and probably use maths. And I mean, it's a common saying as well, a computer scientist is a lazy mathematician. If you're getting involved in AI, I would expect that you would at some point, if you're going too much into research, use mathematics. All right. Would anyone like to add something?
Have you guys written any like just algorithms that you've made yourself, or is it always just something that other people have done? Have you just written your own personalized machine learning algorithm?
So if you really analyze the word research, it's searching again, right? So you always building on the top of what other people have done, right? So if you're building on the top of what Newton discovered 200 years ago, like when you're doing an optimization algorithm, for instance. So everything, it's just building on the top of other people's work.
I think that depends also what you want to do. If the novel thing is the application, so you get the off-the-shelf methods and say, show how it performs in this new application, and what are the challenges with the new application. So it would be a slightly different approach to the research about it than if you're having a preset problem that everybody knows about, and then you want to provide a new approach for solving it, a new way of thinking about it. Then in that case, you need math, you need algorithms, you need to be able to discuss the complexities sometimes to a certain extent. And in that case, then the libraries are just tools for you to implement your math and your I guess algorithm for the known problem.
I think it's the matter of comp sci and engineering, right? So you're really studying that problem, or you're using the things that are available as tool. that's the way to look at it. At least that's the way that we look at it. Are you engineering something, or are you?
I want to add to that. Sam mentioned how he did a lot of physics as well to the tightening of stuff for a particular case. Or I was just thinking, what would you say is more important? Is it more important to really delve into being a pure machine learning expert, or is it better to go into some particular industry area and have that particular knowledge in that area, like really go into finance, for example, but not go into machine learning as deeply?
Well, so this question is basically,
I think it comes down to personality.
Yeah, this question is basically, should I prefer chocolate ice cream or strawberry ice cream? You know, this is what motivates you. It's what you want to seek. Because I can tell you, oh, look, work as just off the shelf things, and that might make you feel miserable. You might hate going to work for doing that every day. You really wanted to go to maths, you know? It's very personal.
We're a bit short on time, but if there's something more that speakers would like to add.
Yeah, I should just mention in passing, we're always looking for new people to join the team. We're always looking for new industry projects. We currently have 446 GitHub repositories. 224 of those are not forks. So please check out our GitHub and drop me an email if you want. You know, depending on the month, we might have 20 engineers. So we're not huge, but we're decent. And charity, check out our charity website and see if you want to get involved there. We were going to be running screening programs by now, but coronavirus, I think everything's going to be delayed until probably March.
You really want that job tonight.
Less research, or is it more just research people?
We have engineers, right? We have a machine learning engineer group, and I think they do it's similar to research, but they have more connections to industry, and they working on some real applications.
We have opportunities for like particular projects. So sometimes we need engineers like for 3 months for a particular project. That could be a good opportunity to come on board, you know, experience, get some exposure, get you know, to know people. And then if you want to stay longer, then you can talk to engineers or talk to researchers and see what's the opportunity for you to stay. So we call them engineers. So
not researchers.
So the engineers. So we have researchers, and then we have software engineers. The software engineers basically, you know, they prepare the interfaces, they prepare the data loaders. They kind of are more connected to the industry, to our clients. And then there are, you know, research side of it, which is basically the people who know the technology or can develop new algorithms for those technologies, or are expert in particular, you know, application. And then you want to, you know, connect that to something that's more real world. Then that's where the engineers usually come in.
And also other things that you guys might want to consider is just come along, say hi. You know, with this COVID thing, it's quite limited. But you can always shoot an email to one of our academics, to one of our research fellows. We always have lots of projects available that you might get a little bit of expertise in AI or in deep learning. You might learn something, you might have good fun, make good connections, and it might evolve that you want to pursue a research career. We have PhD available for people that have finished their honors or are about to finish their honors. We are always looking for people. This actually might increases your chance in the future to get an industry position, like in Google, for instance, all right? Because Google also hire researchers.
Definitely.
Yeah, all right.
Yep.
So maybe you could just pursue your research career here in Adelaide. How cool is that?
Yeah,
in one of the biggest groups.
And we have a lot of like honors. So if you have honors, you're looking for honors project, you can usually approach researchers and our professors, and then see if there is a project for you to do, and you do it for 3 months, and take it from there.
And I should comment also, like Google themselves are always looking for people. So don't be afraid of the logo. Just apply. In terms of my company, obviously my company's different to the panelists' company. Feel free to email me, samuel@offscale.io. I'll make sure that the organizers also send that around to you. Would be great to connect, even if it's bookmarking an email, and you'll get to me in a year once you're more confident with what you've learned in last semester.
And I'd
It's about confidence, not experience. It's about skill, not experience. I don't care if you're a first year or you're a third year or you've got a PhD. What I care is, can you solve this specific problem that's in front of me?
Yeah, and exactly following on from that, if you're interested in AI and ML, I think the best thing you can do is try it. Get out your laptop, download some code, and try and run something, play with it, see what you can make out of it. There's lots of tutorials online these days. You don't need a PhD to be experienced in machine learning. And yeah, I'd just say keep that in mind. If you're interested, just try and build something yourself.
In terms of tutorials, just want to have a quick mention on Google's very own machine learning crash course. Very accessible on the internet, and it's a great starting point, especially also with AI/ML. They also have researchers always keen to help out students from all different years with their enterprise in AI or ML.
Just maybe stay away from YouTube videos that say you can do it in 5 minutes.
Yeah, except for this YouTube video. All
that was a quick 5 minutes.
All right. So we'd just like to thank everyone for being here tonight. Quick shout out to all our partners tonight, and AIML. Thank you for sending all the amazing speakers here tonight. Thank you to our speakers. Thank you to our partners, deeplearning.ai, Google Cloud, and Google. Thank you to the audience for being here, and it's been amazing. And I hope you still have questions. Jump on the Discord channel for DSC at the University of Adelaide. If you don't have access to it, let one of us know. We're here for another 5 minutes. And yeah, the goodies will be given to you soon as well. Thank you.
Thank you.
And also thank you to the audience online from YouTube. Sorry.